All right, well, hello, class. Today we are going to be discussing or talking about square roots and cubed roots. So first we're going to set up our paper. Like I said in class, there's no graphic organizer for this topic, but we are going to set up some Cornell notes. So you should have a loose leaf paper out. You can either fold your paper or draw the lines. I'm going to draw the lines right here on the board. All right, so for our heading today, it's going to be square roots and cube roots. All right, so before we start, we do have to talk about some prerequisite knowledge that we might or we will need to have for this topic. So the first thing is to graph and order real numbers. We're going to graph and order real numbers. So we're going to do this on a number line. So first we're going to have a set of numbers. So our set of numbers is going to be in this brace. Again, if yours kind of turns out to be just a wiggly line, we'll work on that. You'll have plenty of chances during the year. So for this set of numbers, we're going to have the square root of 20, 4.7, 12 over 3, and 4 and 1/3. And then again, we're going to close our braces. So now that we have our set of numbers, we want to put those numbers into decimal form. So when we're comparing them, we're kind of looking at numbers that look alike because this kind of looks all over the place. So first, let's start with the square root of 20. So if you go to your calculator and you do the square root of 20, hopefully most of us are able to do that. But on a graphing calculator, you would do the blue button second, and then x squared. It has a little square root above it, and then you'd hit in the number and press enter. So if I go to second square root of 20, it's going to be 4.47, okay? I rounded there. And then we have, next is already in decimal form. We have 4.7. I am going to add a 0, though, just so those numbers look the same. If I have, rounded to the 100th on one, I want to round to the 100th on the other. And then 12 divided by 3, or 12/3, is going to be 4. And then 4 and 1/3 actually is 4.33, and that 3 repeats. Okay? So now that we have the numbers, we're going to order them from least to greatest, So we're going to start right here with 4. 4 is going to be our least. Now, when we order these and we put them back in the braces, you want to write or you want to refer to those numbers as they were in your original set up here. So for 4, we're actually going to put 12 over 3. Okay? And then next would be 4 and 1/3, and then the square root of 20, and then 4.7 being the greatest. Sorry, that 4.7 is looking a little crazy over there. And then close our braces. So now that we have the set, we put them all into decimal form, and now we've ordered them from least to greatest, we can put them on a number line. This, again, should be a review for you. You should be familiar with ordering numbers and putting them on a number line. So first I'm going to draw my number line. Okay, since all of my numbers are between 4 and 5, I'm going to put my 4 down here, and I'm going to put my 5 over here. And then I'm just going to go by 2, so 4.2, 4.4. I'm trying to space them out so at least they look kind of. And then, of course, we can go back, and that would be 4.1, 4.3, 4.5, 4.7, and 4.9. So now that we have them all listed on the number line, or our number line is filled out, we can go back and place them where they need to be. So 12 over 3 is 4, so we're going to go right to 4, and we're going to put a dot right there on the number line. And you could put above it, you can put 12 over 3 if you want. Then we have 4 and a third, which is 4.33. So it's going to be just about here. Then our next one is going to be 4.47. So there's 4.4. So we're going to be about right there, 4.47. And then finally we have 4.7, and we know that that's right here, 4.7. So we've converted our numbers into decimals, we ordered them, and then we were able to graph them on a number line. All right, next we're going to look at, and this should also be a review, stuff that you have seen before. We need to know how to... Okay, I do apologize about the gap right there. They were calling me over the PA system, so it did take me a minute. So if there was a little bit of gap in your feed, I do apologize about that. So like I said, we're going to now look at writing repeating decimals as fractions. So we're going to write we're writing repeating decimals, not fractions, decimals as fractions. So if you remember when we did this, well, we didn't do this, but when you did this before, you're going to put a 9 in the denominator for each digit under the line. So, for example, so we're going to put a 9 in the denominator for each digit under the line. And what I mean by line is the repeating decimal line. So for example, if you have 0.39 and the 3 and 9 are repeating, when you go to write that into a fraction, you're going to put the number on the top, 39, and then since there is 2 digits, the 3 and the 9 both repeating, you're going to put 2 9s. Okay? Now, of course, we are not going to leave it as 39 over 99 because, like we stress, you have to reduce all of your fractions. So I can divide the top and the bottom by 3. So that leaves me with 13 over 33. And that would be your answer. I wrote 13 again. Sorry about that. 13 over 33. All right, another example. So let's say if you have 0.3 and the 3 is repeating, well, we're going to put the 3 on the top and 1 9 on the bottom because there's only one digit on the top, so you put 1 9 on the bottom, and of course we can reduce that to 1/3. All right, again, we will work more with these topics in class when I see you guys again. All right, finally, we're going to look at simplifying roots. We're going to simplify and approximate roots. Okay, so before we get into this, I'm just going to talk briefly about some notation. Some of you might be familiar with this, some of you may not, so I'm just going to take a second to go over it. So when most of you I'm sure have seen this sign, and that is the square root sign, right? Again, that should be a review. But now we also are going to introduce this, and that is the cube root. So we're going to need to be familiar with those two notations as we move forward. Okay, so we do have couple topics when we look at cubed roots or cube roots and squared roots, and those are perfect squares and perfect cubes. So the list of perfect squares, and again, eventually you will have to memorize these, and you will continue to see perfect squares and use them all the way up through the math courses you're eventually going to take. So with perfect squares, we have 0. 0 is a perfect square, perfect everything, and so is 1. And then it goes 4, 9, 16, 25, 36, 49, 64, 81, 100, and it goes on and on. The list goes on. And when we looked at perfect cubes, we have again 0 and 1, because like I said, those are perfect everything. So 0, 1. Now the next one would be 2 times 2 times 2, right? Because when we're talking about cubes, we need to do it 3 times. So 2 times 2 times 2 is 8. And then we have 27, 64, 125, 216, and those continue to go on. So for the next class, you will not have to memorize those, but we will get to the point where we're going to know, especially those perfect squares, you need to be on the ball with those. Okay, so now let's look at an example. So for our example, we have the square root of 4 over 121. Okay, now you'll have your graphing calculator. So what I don't want you guys to be doing is going in there and putting in the calculator, typing in the calculator the square root of 4 divided by 121. But what you need to do is we're going to look at it and break it up into 2 separate parts. So we can say the square root of 4 over the square root of 121. And when you were working with squares, that's perfectly acceptable to do. Well, now we have it into a little bit of a smaller chunk that we can manage. If you put the square root of 4, or if you just know the square root of 4 is 2, right? And then the square root of 121, again, you could put in your calculator, is 11. So our answer here is 2 over 11, or 2 11ths. Again, we don't want to, when you start with a fraction like this, we're looking for a fraction, not for a decimal. All right, another example would be the cubed root of 216. Now, if you go in your calculator, you can go to Math, the Math button. It's going to be kind of in the top towards the left-hand side under the second and the alpha. So Math, and then you're going to choose number 4. Then you enter the number. So in this case, it would be 216, and then you press enter, and it should tell you that the cube root of 216 is 6. Okay? All right, moving forward, let's say that I give you the cubed root of 180. All right, so that was the third interruption. I guess the end of the day is not the best time to be making these videos, but I want to make sure I got them on in time for you guys. All right, so like I was saying, we have the cube root of 180. So now this is a situation where you can put it in the calculator. So when you type in, right, we go back up to here. So you do Math 4, then type in 180, and enter, and that's going to tell you, and then it's approximately, so we don't want to put this, because when you're rounding, it's approximately 5.6, and I'd round to the nearest tenth unless otherwise specified. So on a test, or on a state test, or the SMI, or the pre-assessment, it should tell you to round to the tenth or the hundredth. All right, so the next and final thing that we're going to need to be able to do is to estimate to the nearest whole number. Move that down just in case you guys need it. So estimate So, for example, if we have the square root of 15, and that comes out to be 3.78 and so on, we need to be able to estimate to the nearest whole. So, right, we know how to round. We've been rounding numbers for years. So, since 3.78, we are going to round that to 4. So then, when we round to the nearest whole number, that's approximately 4. Another example, if we take the cube root of 80, well, that's 4 point something, 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 something. Since it's lower, 4 or lower, we're going to round down. So that's approximately 4 also. I think when you do that out, math, 4, 80, enter. 4.3086 and so on. So since it's 4.30, 3 is smaller or lower than 5, we're going to round that down to 4. So we also need to be able to estimate to the nearest whole number. All right, well, that is the lesson for today. Don't forget to go on and do that quiz, and I will see you in class where we get to work on some of these problems.